There are 6 major biomes on planet Earth. One of the major limiting factors for what defines a biome is the amount of water. 2 biomes, freshwater and marine, are in the water. And so the limiting factor there is the amount of salt. No salt, you have a freshwater biome. Salt above a certain level, you have a marine biome or a saltwater biome. The other 4 biomes are desert, grassland, forest, and tundra. Desert should be pretty familiar to people. Deserts have less than 20 inches of rain in a whole year. About 20% of the Earth's surface is desert. They can be hot or cold. It really has to do with the amount of water that falls. Grasslands are pretty wide open region dominated by, you guessed it, grass. They are generally warm and dry. Some grasslands do have some small trees, but really the dominant plant in grasslands are grass. Grasslands are kind of in regions where you have more rain than a desert, but not as much as a forest, our next biome, and it just does not support large plants like trees. Of course, the next biome is a forest. The forest is dominated by trees. You can have deciduous forests, which are trees that lose their leaves in the fall, or coniferous forests, which are trees that do not lose their leaves in the fall. All rainforests are forests. Again, it's the amount of trees that defines a forest. Okay, about 1/3 of the planet is covered by forests. Forests Forests contain most of the world's terrestrial, meaning land-based, biodiversity, which means there's more variety of terrestrial animals in forests than there are other places. The last biome is the one that is probably least familiar to us, and that is the tundra. Tundras are extremely inhospitable. There is not much that lives there. Um, they, generally speaking, have the lowest temperature of the rest of the biomes, with the average yearly temperature being up to negative 34 degrees Celsius, which is negative 29 degrees Fahrenheit. Not much precipitation, 6 to 10 inches, so less than a desert, but tundras tend to actually be pretty wet because they are so cold, evaporation doesn't happen very fast. You will often find a special type of soil in tundras called permafrost because it's so cold that even at the height of summer, the ground never completely unfreezes. The top layer might unfreeze, might thaw, but underneath that, the ground is still frozen throughout the year. These are the 6 major biomes. And of course, you can have different subbiomes. So we talked about there's a rainforest, there's also deciduous forest, coniferous forests, different types of forests, different types of grasslands. There's tundras and taigas, which are both types of tundras. It gets complicated, but you just have to remember the 6 basic: freshwater, marine or saltwater, desert, grassland, forest, tundra. If we take a look at North America, at the United States, Canada, and Mexico, we can kind of, just at a glance, notice where some of these, or where the biomes might be, right? Just looking here, we can see that up here, up here, it is, you can see white, implies snow, implies cold, okay? You can see here is brown, implies not much vegetation, although over here it's kind of brown as well. Okay, and way over here you have a lot more green. So just by that, we can begin to think about where the different biomes are. We know up north it's colder, Okay, and down south it tends to be warmer. So we're not going to find, say, the tundra, which is defined by cold temperatures, down here. Up here tends to be tundra. All right. So let's take a look. I have this is kind of a special map. It's got a layer on it. I can turn on and off. Okay, if we go all the way out, these are the terrestrial biomes. Again, notice already there are more than 6 listed here, but there are 6 major, and then you can go into like sub-biomes. But just at a general glance, you can see that, okay, all this area, Eastern North America, is all one color. Here's the center of the country. If you think about the center of the country, you think about wide open, flat-ish spaces. Okay, so think about what that might be. Okay, this color here is brown when we take this layer off. Okay, and we'll talk about why this is a different color. This is, which layer is this? This is tropical, subtropical, coniferous forests. Okay, and that's actually related to this and related to this. All right, let's turn this layer off for a second. All right, our weather comes from the west, okay, and blows this way. So this area right here is considered a temperate rainforest because it gets so much rain. There is a line of mountains, the Rocky Mountains, down the center of our continent. Okay, to the east of that line of mountains, all of this area, okay, is grasslands. So let's turn that layer back on for a second. Okay, let's see if I can leave that line up. I'm going to outline on this map approximately where the grasslands are. Okay, and then I will turn off this biome layer. Oops. I guess I can't do that. Okay, so let's just take a look. Right. So you can, oh, there we go. Figured it out. So this is the outline of our grasslands. And you can see they look drier to the west and they look greener to the east. And then if you keep going east, right, all of this are forest. Okay, this is all forest. Let's go ahead and make that a different color. So let's say this is all forest. Okay. Remember, we said right down the center is the Rocky Mountains. So the way this works is the Rocky Mountains basically deflect the weather up north, and then when it comes back down, let's make that blue, deflects the weather up north, and when it comes back down, right, it heads, and that's where we get our weather that gives us lots of rainfall over here in the east, but the grasslands don't get as much. Hence why just to the east, here are the Rocky Mountains, just to the east of the Rocky Mountains, that's where you get the grasslands. Continue east where the rain starts to fall, and you get the forests. To the west of the Rocky Mountains, you get the desert, right? And then right along the coast, because it's close to the coast, and so you get a lot of rainfall, you get a rainforest up here. And then this area right here along California is some of the best agricultural land in the country because it's temperate temperatures and lots of rain. Okay, and you can see all of that. Let's erase all of this. You can see all of that here. Right? So up north, we didn't talk about the tundra in this, but the tundra also stays wet and cold. Okay, but you can really see the biomes blocked out. Of course, out in the ocean, that's the marine biomes, the Great Lakes, and all the rivers in the country are the freshwater biomes. They're hard to see on this map, but we know that they're there. Let's zoom in a little bit, right? because I want to show you, okay, if we zoom in, right, you can begin to see the shape of the mountains here, right, and you can really see that here is desert. This is high desert, okay, so look how dry this is, right? You can see all of the erosion and runoff from the streams, but it is very dry, scrubby land, right? Not much green at all. From here, if we zoom back out, we can look a little bit to the east and see how things change. So zoom, zoom, zoom. Let's take a look. So now that we have zoomed out, we can kind of turn our biome layer back on, and I'm just going to highlight, or I'm going to circle this area. Oops, let's turn that off. I am going to highlight this area right here, okay, just part of it. Let's turn that off for a second. Let's turn our layer off. Okay, so this is the layer I just highlighted. And if you look carefully, you can see that that looks a little bit different than the surroundings. Okay, that is a ridge, part of the mountainous terrain. So let's look back here. So you can see this is the transition zone between desert and grassland. The yellow is desert, the light green is grassland, the darker green is foresty areas. So you can see there's actually some ridges, and then between the ridges it transitions. Okay, and when I mean between the ridges, I mean here, right? It transitions from desert to grassland, right? So you should be able to see all of that just by the colors. And if we look, okay, it doesn't look a whole lot different at this scale, okay, because remember, there are different, this is the spot we were looking at. Okay, so all of this is grassland, okay, but this over here is grassland as well. So okay, so all of that is all grassland. It's just it's different kind of microbiomes or different subbiomes, right? Here is a drier scrubland. Here is probably a richer, fuller grassland, but they're both grasslands. All right, let's continue to zoom out a little bit. Now we're looking at the entire continent, and you can begin to see the patterns. So that area we were just looking at, right, this area between those two passes was the transition zone. To the west of that is desert. To the east of that is grasslands. Okay, so I'm going to go ahead and circle the area that is grasslands, just roughly. Right. Notice up here in the north, the grasslands transition directly to, oops, let's turn this back on. The grasslands transition directly to what's called boreal forest or taiga, okay, which the north is pretty much strongly taiga. On the east, it becomes temperate broadleaf mixed forests. Okay, to the west, there's the range of mountains, and then it becomes desert. All right, but let's turn that back off. This is all of the grassland, right? And just from here, even you can see the western part of the grassland is drier. It's closer to the mountains. The eastern part of the grassland is greener, which means more moisture. And here, the grasslands protrude all the way to past the Great Lakes. That has to do with weather patterns, right? And it gets complicated, but the biomes in a given area are affected by weather, okay, affected by patterns. So if you look again here, let's change our color, okay? You have weather, you have moisture coming in from the Pacific, blows along here, So this is actually considered a temperate rainforest. Okay, the weather kind of goes up through Canada and then kind of comes back down. That's the general weather pattern. So the moisture goes up, feeds the taiga, feeds the temperate forests, okay, gets deflected by the mountain ranges. Again, all of the reasons for all of this are very complicated, but the part to kind of um, just note is that the biomes are correlated with the physical geography, right? So this transition area here is strongly correlated with the Rocky Mountains, with the mountain range, and that affects what can grow where on the entire continent, right? That's one of the reasons studying biomes is important. If you find animals or plants from a certain biome or growing somewhere unexpected, that could be a hint that local conditions are changing. Right? Let's take a look at something else interesting. So if we go over here, okay, let's reorient so north is up. So this is England right here, and London, England is about right there. If you draw the latitude line, okay, the horizontal line around the planet, this is approximately what it is. And notice, if we go out and go to our biome, okay, here on North America, at that latitude, we have taiga. Okay, over here at this latitude is taiga. But over here in Europe, at that latitude, it is temperate forest. Okay, latitude has to do with how far away you are from the North Pole, right, or from the equator. But if at the same latitude you have taiga over here, and you have temperate rainforest, boreal, temperate broadleaf forests over here, how is that possible? All right, and let's turn off our layer and take a look. So approximately here lies the equator, right? Maybe a little bit lower. It's actually, whoops, it's actually kind of here. Okay, so that's approximately where the equator is. There are currents in the ocean. Okay, there are currents that come down here, and because of the rotation of the Earth, they get deflected this way. And then when they get to North America, they get deflected up. We call this the Gulf Stream. It brings warm water up from the Caribbean, but then the Gulf Stream actually runs along this ridge of continental shelf, and it gets deflected back to Europe, where here at this point, okay, it gets deflected back down, okay, where it warms up down at the equator, and that is one cycle. There's actually another, they're called gyres. There's another gyre here, okay, that is cold water, okay, but the key is this is warm water. So this is bringing warmer water to this area of Europe, and that makes the weather at this latitude warmer than it is in North America because of these currents, because of the weather patterns, right? All of that affects, let's go ahead and turn this off so we can turn that on. Okay, all of that affects what biome you have at a certain latitude. Okay, we're going to talk about Africa in a few minutes because it's very interesting and very obvious, some of this banding, some of what I'm talking about with the biomes. But before we get there, I want to show you something more complicated, right? Because it'll make what's going on in Africa make a lot more sense. Right, so here is Asia, right? Just on the left, you can see the Arabian Peninsula, which is very clearly deserty. Up here, you can see Europe, but this is strongly Asia, right? Big chain of mountains here. Okay, here's China down here. Here's India here. Japan lies off the coast here. Let's take a look at what this looks like if we turn the biome layer on. So even already, you can see that this chain of mountains, this chain of mountains has a strong effect on the biomes, right? So you can see that that chain kind of defines what's going on south and west of it is different than what's going on north and east of it, right? Those mountains affect the weather here a lot. But Asia is very strongly oriented east-west. Okay, it's a very wide continent. And so when you look at the biomes, they get very complicated, right? Because you have an east-west orientation, you have these mountains that run vaguely east-west, but with a little north-south. There's the mountain range. So it's kind of very complicated. All right. So in order to understand what's going on there, it's good to look at another region that is very clear, right? And so take a look at Africa. Let's orient ourselves north-south again. Okay, just already looking at Africa, you can see pretty clearly what's going on. Okay, and then before I turn on the biome layer, let's circle a couple of things. Okay, you can see inside of this there is darker green. You can see this, okay, is green. Okay, and I'm going to change the color of my line for a second. You can see that this and up here is pretty brown, pretty deserty looking. Okay, so let's take a look at what that all looks like with our biome layer. Okay, and then let's turn what I highlighted just back on. So that correlates pretty strongly, right? Got my lines maybe a little bit off here, okay, and then a little bit off here, but it's pretty strongly correlated. Now, let's go back and turn this off for a second. Okay, let's get rid of my lines. We said Asia was oriented east-west, right? Africa has a little bit of that up here, but generally speaking, Africa is pretty oriented north-south. And that has a lot of effects on the climatic history, the climate history of Africa, what biomes are where, and that climate history has actually affected the human history of Africa a lot, all right? Because it's oriented north-south, you have strong horizontal banding of these biomes. The equator runs, hold on a second.
So the equator pretty much runs like this, right? And you can see that very strongly correlates with the darker green in the middle, right? With that particular biome, so the parts of it that are closest to the equator are one biome. A little bit further out, up here and here, you have another biome, and then further away, you have your deserty biome, right? Let's turn the layer back on so we can see that. Okay, so here is the tropical, subtropical, moist forests. So because it's close to the equator, it affects how much rain falls there. And so along the equator, at least on the western half of Africa, you have moist subtropical forests. Okay, up here, these are grasslands, savannas, and shrublands. Stereotypically, when we think of Africa, this is kind of what we think about. Your savannas with your elephants and your giraffes and your lions. And it is a lot of Africa, but it's very specifically the areas that are a certain distance away from the equator. And then over here, it's kind of also along the equator because that's far away from the ocean, right? The weather currents come from the west and they travel east, so it's still drier over here, right? Remember, grasslands are drier than forest areas, but not as dry as deserts. and then a little bit further away from the equator on both sides, you begin to have deserts, right? This all has to do with weather patterns. It all has to do with how water comes off of the ocean and falls onto the earth. Because it's so strongly banded and obvious in Africa, it's a great way for us to learn about and understand how biomes happen, how they exist on planet Earth. Now let's take a closer look at one specific part of Africa. So up here, this is northern Africa, and already the thing that should stand out is this green area up here. This is the Nile Delta. Why is there so much green right here, right? And it has to do, of course, because of the Nile River. So the Nile River is, actually, you know what, let's do that blue, because it's a river. Freshwater ecosystem, right? So the Nile River runs like this, and it runs through the desert, and then here, when it gets close to the Mediterranean, right, the river spreads and out. It's kind of what happens when the rivers meet the sea, is it spreads out into what's called a delta, okay? If we turn on our biome layer, you can see all along the Nile and the delta is flooded grasslands, savanna, right? So all along the Nile, and especially the delta, are flooded grasslands and savanna, okay, which is very different than just outside of it, which is desert, right? And when we turn off our biome layer, you can definitely see that, right? Along the Nile, you see growth, you see green, you see life. To the sides of it, at this distance at least, it doesn't look like there's much, it just looks like rock and sand. Of course, there are things living out in the desert, they are just adapted to those conditions. But look here, so this swath of green, okay, is very strongly correlated, and you can see lots of human settlement, because the Nile River is there to help keep all of this farmland alive, okay? You couldn't grow things in this area without the Nile River. So that's a pretty strong indication that, water is one of the limiting factors that affects what biomes are where, alright? And all of this is without getting into the particulars of those freshwater ecosystems or these marine ecosystems. Okay, marine ecosystems are their own topic. We talked a little bit about it when we talked about the hydrosphere. Remember, the hydrosphere is important because that's where the fresh water that becomes rain that allows these areas to grow on land comes from. Without this salt water, we wouldn't have rain. Without the rain, we wouldn't really have much life on land at all. All interconnected, okay, all different biomes that are very specific and different because of local conditions. Now, part of the reason to learn about this is if you have plants that are, say here in this grassland, that are desert plants that are creeping in, it means that the land is going through desertification and the climate has changed. Or if you start getting a lot more rain and grasses start to grow in the desert, it means that the climate has changed in a different way. So understanding how the earth is changing is one of the benefits of understanding what biomes are where.